behave with love.
Good morning, my fellow students. Welcome to Nasarawa State University KEFI Open and E-Distant Learning. We shall start with a course introduction to public administration mathematics, that is PAD112, Mathematics for Public Administration 1. My name is Dr. ODONYE DAUDA Yusuf. I'm the course coordinator for this course, and I will be taking you on mathematics for public administrations. And I just hope that you pay adequate attention and listen and understand. The general objectives of this course is, one, to acquaint students with the basic mechanics, concepts, and operations of mathematics, express public administration's terms in a more precise manner, and to use mathematical models to present simplified versions of how public administrations work. Show the difference between the product rules and chain rules of partial derivative, as well as showing the difference between differentiations and integrations. And it will also to help train the student's mind to be analytical in public administrative decision making, and to empirically measure the cost, benefit, and effects of competing options when faced with the issues of scarcities and choice in administrative work. So we shall start with the first study sessions in this week, which is the number system. What is number system? Number system is defined as the basic terms of number system and its properties. We are going to discuss the types of number systems and their general properties. We shall also explain concisely binary, imaginary, and complex numbers. And lastly, we shall highlight on the number basis. Introductions. A numeral system, also known as system of numerations, is a method of representing or writing numbers using digits or symbols in a consistent manner. It can be seen as the context that allows the symbols, that is 10, put in quotation mark, to be interpreted as the decimal symbol for 10, the binary symbol for 2, or a symbol for other numbers in other bases. The most commonly used systems of numerals is known as Arabic numerals or Hindu's Arabic numerals. These are popular numbers, as all we know or use. So, definitions of basic terms of number systems and its properties. Let's look at these various terms and their properties. One, number system is a way of expressing numbers in writing or the mathematical notations for representing numbers of a given set using digits or other symbols in a consistent manner. Here we have the rational numbers are further divided into integrals and non-integrals. The integers are made up of positives, 0, and negative whole numbers, while the non-integers are purely fractions, which can appear in forms of either vocal, decimal, or percentages. For example, you can say 3/8 or 0.38 or 38% or 50%, etc. are the three forms of the fractions respectively. The positive integers, which are 1, 2, 3, they are sometimes called counting or natural numbers. They are grouped into odd, even, prime, and composite numbers. Definitions of basic numbers and their properties continue. So let's look at what is odd numbers. Odd numbers are the natural numbers that cannot be divided by 2 without a remainder, or can be divided by 2 with always a remainder. Example, we have 1, 3, 5, 7, 9, etc. These are odd numbers. Even numbers are natural numbers that can be divided by 2 exactly without a remainder, or they leave no remainder when divided by 2. So for example, we have 2, we have 4, 6, 8, 10, 12, etc. Prime numbers are natural numbers that can be divided by themselves and 1 only without a remainder. Or I say the prime number, their number can be divided by themselves only and 1. Example are 2, 3, 5, 7, 11, 13, and so on and so forth. The last concept is the composite numbers. On the other hand, are those natural numbers which are not prime numbers, but can be divided by other numbers aside themselves exactly without a remainder. They can be divided by themselves and other numbers without a remainder. For example, we have 10, we have 12, we have 14, we have 15, we have 16, we have 18, we have 20. All these numbers can only be divided by themselves without a remainder. So let's look at these features of a real number system. The diagram, the chart below shows further on the features of the real number system. So when you look at the chart here on the figure 1.1, you see real number systems. Here under it is the numbers. Under numbers, we have the rational number, the irrational number, we have the complex number, and irrational numbers. So the irrational number, the complex number are out of the scope of our study. So our focus will be on rational numbers. So on the rational number, looking at this diagram, is divided into 2. We have the non-integers and we have the integers. The non-integers is further classified into 3 and called fractions. In these fractions, we have the vulgar, we have the decimal, and we have the percentages, just like what we read. While the integers is further divided into 3 called the negative, 0, and positive numbers. In the positive number that we also found out that it's divided into 4. The odd numbers, the even numbers, prime numbers, and the composite numbers. I think this graph should summarize what you are expected to know. The following should also be noted from the real number system. Put this at the back of your mind as a student. All prime numbers are odd numbers except 2. And not all odd numbers are prime numbers. 2. All even numbers are composite numbers except 2. But not all odd numbers are composite numbers. 3. 1 is neither prime number nor composite number. Have it. 1 is neither prime number or composite numbers. 4. All negative numbers must bear the sign of minus before them, but all positive numbers must not bear the sign of plus written before them. E.g., you can have -5, you can have -3, you can have -6, and all that. But you must not, it's not necessary for you to have +5, +6, plus this before them. If you write 5, 6, 7, that is okay for positive number. 5. 0 bears neither signs of plus nor minus. 0 does not carry any of these signs attached to it. E.g., can only be written as, you don't write 0, it can only be written as 0 or 0.00 or 0.000. But it's not written as -0 or -0.00 and so on and so forth. So let's look at the number line here. You can see that 0 is just at the middle. It has no sign attached to it. 1, 2, 3, 4, 5 to the right. These are positive numbers, so they must not necessarily carry plus. But all the negative numbers from the left are carrying -1, -2, -3, -4, and so on and so forth. So what are the types of numbers and their general properties? So the basic types of number systems are discussed below. 1, the natural numbers. As we have already highlighted that before now, these are sometimes called the counting numbers. They are used for counting. These numbers are 1, 2, 3, 4, 5, and so on. They do not include 0. Remember, they are natural numbers, but they do not include 0. They start from 1 to 1 million and end to infinity. So we cannot count 0. They also do not have fractions or negative numbers. So, 2, whole numbers. These are similar to natural numbers, just that they include zero. We call it a whole number. They are 0, 1, 2, 3, and so on. Like the natural numbers, these numbers do not have fractions or negative numbers. We have the integers. These are positive and negative whole numbers. These numbers tells us that in real life, some numbers can fall below zero, like temperature. You can say this when temperature has gone below zero. So some examples of these numbers are 4, 3, negative 4, negative 3, negative 2, minus 1, and so on and so forth. Or 0, 1, 2, 3, 4. They do not include fractions. Then we have the natural numbers. Any number that can be written in fractions or ratio form is called a rational number. They include all integers, e.g. 4, 3, which can also be written as 4 over 1 and 3 over 1, and all fractions, e.g. 4 over 5 and 2 over 6, and so on and so forth. Irrational numbers. These numbers cannot be expressed as fractions. They cannot be represented as terminating or repeating decimals, e.g. the square root of 3 is equal to 1.7320508, n equal to 3.141592654. So it is, these numbers are non-ending and non-repeating decimals. So the number 6 is your imaginary number. These are special numbers because when squared, they give a negative result. They are called imaginary numbers. That is I to the power of 2. That is equals to minus 1. Thus, I is equal to the square root of minus 1. Imaginary numbers are important because they are useful in solving problems involving the square root of negative numbers. They are useful because they are used. So, example of such number is 2i. Then, we have the real numbers. These are whole, rational, irrational numbers. All numbers except imaginary numbers are real numbers, are called real numbers. Example, 1, 1 over 2, 0, the bar, and etc. Complex numbers. This is gotten as a result of two sets of numbers, real numbers and imaginary numbers. So when you talk about complex, where you're having two, we have real numbers and we have imaginary numbers, where each set can be 0. The general properties of number systems are: 1, closure. If you operated on any two real numbers, a and b, with plus, minus, times, or stroke, you get a real number. We talk of the closure of that. Cumulative numbers. We have x plus y will give you y plus x, and x times y will give you y times x. So we call it commutative. Then we have associative numbers. When you open bracket, x plus y, close the bracket, plus z is equal to x plus, open bracket, y plus z, and x times y in bracket is times z is equal to x times, open bracket, y times z, close the bracket. So then we also have inverse. Inverse, you can say x plus minus x is equal to 0. That is x times, open bracket, 1 over x, close, is equal to 1. So identity, x plus 0 is equal to x, comma, x times 1 is equal to x. So then that is identity. Then we have distributive. Say x times, open bracket, y plus z, close the bracket, is equal to x times y, open bracket, close, plus, open bracket, x times y, times z, close the bracket. So let's look at the binaries number now. A binaries number is a number expressed in the binary numeral system or base 2 number system, which represent numerical values using two different symbols, typically 0 and 1. And these binary digits are what the computers use, 0 and 1. The usual base is 2. System is a positional notation with a radix of 2, e.g. decimal 2 is binary 0. Decimal 0 is binary 0. So when we say decimal 0 is binary 0, we can equally say that decimal 1 is binary 1. However, decimal 2 is binary 10. Decimal 3 is binary 11. Decimal 4 is binary 100, and so on and so forth. Example, each digit 1 is a binary number representing a power of 2. So, and each 0 represents 0. For example, 01 is 2 to the 0 power, or 0 times 2 to the power of 1 plus 1 times 2 to the power of 0, which is equals to 1 to base 10. The same thing 0010 is 2 to the 1 to the first power, that is 0 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 0, which is equal to 2 base 10. So, and those examples continue like that. So when you see a number in base 2, you can figure out what the base 10 is by adding the powers of 2. So when you say 0, for example, 0101 is equal to 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0, which is equal to 0 plus 4 plus 0 plus 1 is equal to 5 base 10. So you can pick the next example. 1010 is equal to 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 0 is equal to 8 plus 0 plus 2 plus 0, which is 10 to base 10. And this example continues. So let's look at the complex number. The complex numbers are formed by real numbers and imaginary numbers. They are formed by real numbers and imaginary numbers. A complex number is a number that can be expressed in the form of x plus yi, where x and y are the real parts, and yi is the imaginary part, as it has I, which is the imaginary unit. That statistics, this satisfies the equation I to the power of 2 is equals to minus 1. So you can see the diagram here, the complex number diagram. If you check, you will see y and the x-axis. So the arrow is pointing to where you have x plus y and I. So performing operations involving complex numbers. So let's start with additions. Example, when we say open bracket 3 plus 6i, close the bracket, plus 4 minus 2i, close the bracket, is equals to 3 plus 4, open bracket close, plus 6 minus 2, open bracket close, I is equals to 7 plus 4i. So subtraction now, when that is for plus, for subtraction, you can say, okay, 8 in bracket, 8 plus 4i, close the bracket, minus 6 plus 2i, close the bracket, is equals to 8 minus 6, close the bracket, plus 4 minus 2, open and close the bracket, I, which is equals to 2 plus 2i. Note, additions or subtractions of two complex numbers will give a complex number multiplication. You should note that the additions or subtractions of two complex numbers will give a complex number multiplications. For instance, when you have open bracket 3 plus 2i, you close it, then open bracket 4 plus 5i, you close it. We give you equals to, you bring out 3. So now you are having open bracket 4 plus 5i, close, plus, you select 2 again, is equals to 4 plus 5i, you close the bracket. So if you collect the like times now, you will see that 12 plus 15i plus 8i plus 10i. Then you will now have 12 plus 15i plus 8i plus 10. Open bracket minus 1, close it. So recall that I to the power of 2 is equal to minus 1. So if that is the case, we cannot say 12 plus 15i plus 8i, it will be minus 10. You understand? So that will not give us, if you say 12 plus 15i, so that will not give you 2 plus 23i. So also, the product of two complex numbers gives a complex numbers as seen in the above example. So number basis. So let's look at the number basis. A number basis can be represented in several ways, with it still maintaining its value irrespective of the way it is represented. Example, the number 01101 and 13 are different ways to represent the same number 13 in different bases. Below are some common examples of the number basis representations. We have the decimal number. These are the regular numbers we are used to, and they use digits from 0 to 9, e.g. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And they are base 10 numbers. A number 2, 3, 4 to base 10, which is a 3-digit number, can be written dot 2 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 4 times 10 to the power of 0, which is equals to 2 times 100 plus 3 times 10 plus 4 times 1 is equals to 200 plus 30 plus 4 is equals to 234, which is 234. We have the octal number. The first we have dealt with the decimal, now the octal number. Another number system is the octal. The octal numbers system, which is a base 8 number system. This number uses 8 digits from 0 to 7. So we have 0, 1, 2, 3, 4, 5, 6, and 7. So in base 8 number system, the digits 0 to 7 are same as the decimal system, but from 8. They assume different values. For example, 8 in decimal number system is 10 in the octal system. Below are examples of the base 10 numbers and their base 8 equivalents. So we have 8 to base 10 minus 10 to base 8. So we can also have 9 base 10 to 11 to base 8. So 10 base 10 to 12 to base 8, and so on and so forth. You may be required to convert from one base to another. This is how to do it. Thank you. So let's look at some of the example of this conversion. That 53 from base 10 to base 8. So step, you divide the decimal number by 8, then the quotients and remainder will be 6 and 5 respectively. Step 2, the quotient 6 can't be divided by 8. Step 3, to obtain the resulting number, write down the last quotient first and the remainder from the lower level to upper level. The equivalent octal number is 65 base 8. To verify if this is correct, let's convert our result back to base 10. When you say 68 base 8 is equals to 6 times 10 to the power of 1 plus 5 times 8 to the power of 0, which will be equal to 48 plus 5, which will be equal to 53 base 10. I hope you are following. Thank you. So this is a summary of what we are expected to know in real number system. We thank you for listening. God bless you.